Hi, my name is Gábor Sárosi. I'm from Hungary. I was born in Budapest. Did all my schools and my PhD in Hungary, and now I'm a postdoctoral researcher at CERN in Geneva.
Tell us something about yourself that's not related to physics.
Well, I like to play the guitar. I had a rock band. I don't have it for a few years now. It's difficult to maintain a rock band when you need to move every 2 or 3 years. But I still like music. I also like playing video games. I have successfully infected my wife with this habit too, who is also kindly helping me to make this video.
What other topics excite you about theoretical physics?
Well, one field that had a lot of recent developments that I find very interesting is the conformal bootstrap. The reason is that as theoretical physicists, we like to say that the only systems that we can really solve analytically are the ones that we can turn into a harmonic oscillator. And this is really not like it. So in conformal bootstrap, you use some consistency conditions and some technology to extract exact results about very strongly coupled systems that cannot be further away from harmonic oscillators. And I think that's very exciting.
Why is this a good time to be in theoretical physics?
In the history of humankind, this is really the first time, these past few decades, when we can meaningfully address profound questions like what space and time are made of. And before these were kind of in the realms of philosophy, and now it's an actual scientific question that we have mathematical tools and etc. to address.
Is there a particular research topic or idea that inspires you?
One physicist I look up a lot to is was Joe Polchinski. So I had the fortune to spend some time in Santa Barbara in 2015 before he passed away. And his approach to research, his excitement, and just how decent human being he is a great inspiration.
What's your coolest result?
Well, always the latest one. But jokes aside, really, like in my last paper, we have been able to calculate a thermal two-point function exactly as a function of the coupling, interpolating between weakly coupled and strongly coupled regimes, and this is the first time ever such an object has been calculated in any system, so I think that's pretty cool.
Tell us about an unusual place where you've had a physics discussion.
Very memorable for me is a discussion in lobby of a New York City hotel where we were attending Simon's yearly meeting with my colleagues from Philadelphia, and we sat down after the talks in the lobby to wait for something, and we came up with an idea and sat there for a couple of hours and essentially worked out everything, and in the end we basically had a paper. It took a couple of months afterwards to actually write it down and dot all the I's. But yeah, so that was very memorable for me.
What will you be talking about during your seminar?
Well, I will be talking about my results on quantum chaos and the quantum butterfly effect. Recent years, thanks to holographic duality with gravitational systems and the development of new class of solvable models, there was room to make a lot of progress.
Thanks, Gábor.
Well, thanks a lot, Dio. Take care.